Hello, everyone. Okay, so today we're going to talk about in electrodynamics, which I'm going to share my perception and understanding of that. Electrodynamics, as I understand it, and please confirm this for yourself, but that describes our circuits that we use today. So if we have a battery, and we have a plus and a minus, and then we have a light bulb. I'm going to draw, this is supposed to be a light bulb. And then we go back to the battery. And this is for a 12-volt light bulb. And this is the switch, the on and off switch. On, off. So if electrodynamics says that the battery is powering this light bulb, one question I'm asking is, does the battery power the light bulb? And Thomas Bearden, if I understood what he's sharing in his literature, his books, and his theories, there's lots of videos on YouTube and social media of Thomas Bearden sharing his ideas, which is based on his research, which I think we could say is based, maybe we could say it's influenced by particle physics, which is a deeper understanding of what's taking place, right? So if this light bulb is emitting light, and this is the battery, does the battery power that light bulb? Okay, now I'm going to try to think about what I've learned, and I hope I've learned something. I'm doing my best. My understanding is this kind of circuit. This is a short circuit right here. Okay, let's just say this is on. This is a short circuit. We're discharging this battery at the rate of powering this bulb. That's one layer of what's taking place. Before I made this video, I thought I knew clearly what I wanted to say. There's another kind of circuit. Let's say this is a 24-volt battery. And this is a 12-volt battery. Now this could be two 12-volt batteries wired in series, right? To get 24 volts. And if we have a light bulb, plus, minus, if we have a light bulb, let's connect this, let's connect the two negatives together. So this negative will connect to this negative, and then the positive, we'll take the positive and run that through a bulb, and that's going to be it'll still be a 12-volt bulb. Okay, this is my bulb. It's not perfect. We'll call this splitting the positive, right? That's making light. But what's happening with the energy in this example here? So this is a separate example up here. This is a separate example down here. This example, we are charging this battery at what's called the rate of powering this bulb. And we don't lose energy here. All the energy goes here. And then this can be two 12-volt batteries in parallel. So then we can wire these in series and then these in parallel if this is two batteries. If this is two 12-volt batteries wired in series. And then we can go back and forth, right? And then also, we could run a generator. Instead of running a light bulb, maybe we could run a motor. We could run a motor. This is my motor, okay? This motor is turning, I'll say it's turning a generator. Okay, this is supposed to be a generator. This motor's turning a generator, and this generator can be charging this set. I would charge this set of batteries. So as we're sending this energy, all this energy over here, we could be still powering the light bulb or not, but I think I would run the generator or the bulb, not both in this example, because I don't know what would happen. This would probably be very dim. And also these could be different voltages. This can be, I've done this test with higher voltage. I've used 48 volts and a lot higher voltage. We have to be careful on this side though, because we don't want to get too much heat and overcharge too much over here. So we have to watch that. But this generator can also be wired. So the plus can also go to the plus, and the minus can also go to the minus. I've done this circuit here just as an experiment. And then when we rotate it, we can put more energy. We can do the same thing. We can connect all this over here. So these are in series, and then we're running the generator to help put more energy in here. It's an interesting idea, right? Going back to Tom Bearden, I want to try to think about, I'm going to share my perception of what electrodynamics is. There's a lot of words, right? There's a lot of different words, but I'm going to talk about electrodynamics and particle physics, because Tom Bearden said if the electrodynamics departments can work with particle physics departments, and if they can collaborate and work together, it would just be something that would be very helpful for efficiencies purposes. And I think it would allow all of our circuits to be no less than 100% efficient. No less than that. If we implement ourselves, okay, we can't wait for someone else to do it, right? Because that's kind of like a competition. I don't know if you want to call it a game or what you want to call it, because people just love competition, and there's a lot of competition, and people are competing, and businesses are competing. So, but you have the absolute complete freedom, this is my understanding, to share your mind, to share your thoughts, okay? And some people don't think that's true, but I'm just speaking from my experience. I share everything I know, and I even share a lot of what I don't know. And that's actually what I'm doing right now. I'm trying to share what I'm trying to figure out, okay? So, for people that think they want to make millions of dollars off of selling their inventions, that has been done, and that's not, I don't think that's really helping the world that much, because there's billions of people that want to understand the theory about how the universe works and how circuits can work more efficiently. But when people make discoveries and they just keep them to themselves and then sell the ideas, that doesn't help people that want to learn. So I think everyone needs to learn the theories. If you want to sell your ideas, I think that still can be done. It'll probably make them even more valuable, I'm just guessing, if everyone understands the theory, because there'll be more demand for something. See, right now, if people don't understand the theory of free energy, if I'm just calling it free energy is efficient energy, okay? Like solar is very efficient. And then people say, oh, no, it's not efficient. Well, I'm looking at it like it is efficient, because once we make the solar panel, it produces energy. If I say it that way, I'm just going to say it produces. It's giving us energy for a very long time. Very, very long, many, many, many years. So I'm just talking about efficient energy systems and being able to understand the theory so well that we could even teach our teachers, because our teachers want to learn too. So we have to understand the theory well enough to be able to teach our teachers. So, and that's my experience. They say, teach me. I want to know. I want to learn. So let's think about how, so if we're looking at electrodynamics, and if electrodynamics, I think this is what Thomas Bearden was saying. I think he was saying, because a lot of people comment on how Tom Bearden can talk for an hour or for hours, and we may not understand more than a couple of the words he said, and we may not understand the ideas that he's talking about. And I've studied Thomas Bearden for hundreds of thousands of hours, and it's probably the reason I can talk to you as much as I can about the things I don't know. I'm just guessing that's what's helping me, because I have studied, but when I say I understand it, I don't think I would say that. But some people say, oh, you know so much, Joseph, you do understand it. Well, I don't feel like I understand it, but if you think I understand it, then thank you. But there's so much more to learn. I think that's part of it, is I'm also aware of how much I don't understand. So it's difficult for me to say, oh, yes, I understand, because there's so much more to learn. So let's think about, I think one of the things that Tom Bearden was saying was that electrodynamics, okay, so I'm going to say electrodynamics electrodynamics, okay, not the perfect spelling, and it's very messy, apologies for that. Electrodynamics says, I think this is what Tom Bearden was saying, is that electrodynamics and people that follow just electrodynamics and nothing else, right, says that, I think this is what he was, because Tom Bearden has quite a sense of humor, I'll say it that way, because he says very funny things. And Donald Lee Smith is also very good at that too, making people laugh. If you watch his videos, he's very, very funny. And he's very good at working with people and communicating with people. But Tom Bearden, it seemed like he was saying that electrodynamics says that, I think this is what he was saying, is that electrodynamics, people that say you can't have free energy are usually speaking from a place of electrodynamics, but at the same time, electrodynamics seems, or it does, that's what it looks like to me, claim that you can make energy. And that a generator comes from that language of electrodynamics, where we're saying, you make energy, you make it. And you make it with a generator. And you generate energy, you make energy. But we know in higher physics, right, because a lot of references to electrodynamics might speak of electrodynamics as elementary physics or very introductory level. But then there's extensions, and there's a lot of different ways that we can talk about electrodynamics where it can be more inclusive. But I'm just going to say my impression, and this just could be my complete lack of understanding, which I apologize for that, because I'm sure that is always there, at least partly, because there's so much more to learn. But electrodynamics says you can't make energy, you can't have free energy, right? It says you can't have free energy, but then says that we can make energy with a generator. I mean, it seems like everyone knows that we can't make energy, right? You can't make energy and you can't destroy energy. I mean, that's just common language. It seems like for everyone. But then when we're talking about circuits, it seems like we're talking about, well, yeah, you can make energy. The claim is that a generator makes energy. But does it? Does it make energy? Do the copper coils make energy when the magnets pass by the copper coils? And then if I talk to engineers, they'll say, oh, well, the coils agitate the magnets agitate the coils, and the coils release electrons. That sounds like it's making electrons. If it's releasing electrons, where are they coming from? Do the coils just have an infinite supply of electrons? Does the environment have nothing to do with this? Can a generator exist like without the universe? Like, I don't understand. It just doesn't make sense. I mean, first of all, a generator exists in a universe that's filled with energy, okay? And to me, what's happening is the magnets, right now, this is what I'm understanding I think is happening. The magnets are passing the coil, they're going by the coil, and when they leave the coil, whether it have an iron core or not, when it leaves the coil, when the magnet moves away from the coil, the environment, energy in the environment, the electrons in the environment, right? I don't know if it's electron pairs, like Donald Lee Smith. It could be, right? Electron pairs coming from the sun, a large electron paired with a small electron, and when they push apart, you get amps, and when they come together, you get volts, or it's vice versa. It's one or the other. Amps, volts, push them apart, and they come back together, amps and volts, right? Is that what's happening? And that makes the infinity symbol? And that's the motion of the electron, the infinite electron, the perpetual electron, right? Richard Feynman, Nobel Prize winner, Caltech. Okay, and then Donald Lee Smith talking about the electron that has an infinite lifespan. It goes on forever and on and on and on, and it doesn't break down to anything else because it's a fundamental particle. So here's a question: does electrodynamics acknowledge that the coils are interacting with the environment? There's all kinds of energy out here. Okay, I've had people tell me we do not use the energy in the environment. It's potential energy, but we don't use it. So where's the energy coming from in the coils then, according to electrodynamics? Is the coils making the energy when the magnet goes by the coil? Does the coil make energy? We can say it agitates and makes electrons move, but that's making to me. Okay, where are they coming from? Are they coming from nowhere? Are we just making electrons? This is my question that I have. I'm looking at it like the way that Thomas Bearden and Don Smith, the way I perceive them to be saying it, which is these coils are interacting with the environment. And if you study, when I read about Richard Feynman, John Wheeler, Paramahamsa Tiwari, Paul Pantone, Donald Lee Smith, Rick Friedrich, Russell Anderson, Limitless Energy from the Vacuum, John Searle, SEG, Searle Effect Generator, Thomas Bearden. All these people, there's hundreds and hundreds of people that have experimented and have theories about what's taking place, but Thomas Bearden I place at the top of the theory, and he built the machine too. He also built a motionless energy generator. I don't know if I said that correctly, but there was no physical parts moving, but there was oscillations, I'll call it. Those oscillations were interacting with what I understand to be the environment. But there's many ways to do it, and we already do it. The question is my question is how can the circuit be wired differently so that it could be more efficient, so that we can use the energy longer, right, as a range extender or just more efficiently than we do right now, like this, where the bulb is just discharging this battery and the energy is just going nowhere. It's not being shared, right? It's just ends here, short circuit, right? Versus this, where the energy can be sent back and forth, back and forth, back and forth. And how many more generators can we put here, right? How many more generators can we put here and then charge the charging battery, the battery that's the low voltage side, right? And then we're charging those at the rate of spinning these generators. And the power that these generators are producing or the power these motors are producing, right? This is one wire going through here. A positive wire is running that motor between two positives. But the negative between the two sets of batteries is connected. That's what allows it to work. How many motors can we put in here, which increases the rate at which we're charging these charging batteries, right? Because these charge at the rate of powering this load. So if there's more motors, that's going to be more amps and more volts going to the battery. And then the generators on each motor, a generator on each motor, will be sending more energy to those batteries as well. So it seems like we could just switch back and forth for a longer time period. And this can probably be done with like AA batteries or larger batteries as well. So electrodynamics, I think the people on the internet that say free energy is a scam, free energy is impossible, I think that these are people that believe in, if I say it that way, that have studied, I think it's electrodynamics, which is the circuit that does not acknowledge that there's energy in the environment, does not acknowledge that that's where the energy actually comes from. This is what I think Thomas Bearden was saying. This is what I heard him say, right? I'm interpreting what he's saying, but this is what I heard him say. This is what it sounds like he's saying to me. And he's kind of laughing at this because, well, I don't know if he's laughing, but he's saying it frustrates him because he's saying electrodynamics says you can't have free energy, but then claims that all their generators are making energy when you can't make energy. So the energy is being pumped from the environment into the circuit. And then how does it do that? That's something else I would like to look at. And I don't know how to understand how Thomas Bearden is saying that a circuit works. But I do know that this is something I've wanted to think about with you in a video. So, have a great day. Until next time.